Hi everyone, it's Sorkin. Today we are going to take a look at the 7.CAP theorem and why it's important to know it in distributed systems. Let's first take a look at the opposite of the distributed system, a centralized system, and we have a very simple app which is serving 1000 requests a day. So what we can tell about this system, our system is available and it's also 100% consistent. And let's say that so the demand for our app is increasing, and instead of serving 1000 requests, we are serving 10,000 requests a day. And so we are moving from centralized system to distributed system. So we are changing our architecture a bit. So we are introducing a load balancer, and also we have now two instances of our app, each of which has its own database. Let's call them, for the sake of simplicity, partition 1 and the partition 2. Another important requirement is that these two databases in our distributed system, they should be in sync. So what's that mean? It means that if we are sending a first request for updated balance for a user with the ID 10, and it goes through the first instance of an app and it's updated in the partition 1, so it should be propagated to partition 2. So when we send the second request from the same user, let's say that after 2 seconds or 5 seconds and so on, so we are sending through the load balancer routes that request to the second instance of the app, so we should get the updated balance 50. So in this system, in this distributed system, right, previously we had only two parts of it. So our system had to be, if it's centralized, it had to be available and consistent. So now we are introducing one more part, which is partition. Now we have two partitions in our system. So we have to also manage the partition tolerance. So what's that mean? Let's say that we have a network issue and our system is no longer in sync. So which means that if we are sending a request to the database 1, to the partition 1, it cannot be propagated to partition 2. So what we can tell about this system? Our system in this case, it will be available, so we can tolerate that they are not in sync, but they will not be consistent. So let's say that the previous scenario, right? So we are updating for a user with the ID 10, so we are updating a balance to 50, right? It's updated in the first partition, but it's not propagated to second partition. So our system is no longer consistent. So if we are sending the second request, and the second request returns us 30 because this is the last balance that we had when the system in a whole was in sync. So we have this scenario, right? When our system is available, we have a partition tolerance, but our system is not consistent. What is the other option for us? Other option is that our system, if we want to keep our system consistent, and if we want to the system work when there is a network issue and our system is not in sync, then in that case our system won't be available. So for example, what we can do in that case, we can return a user response right away, something like a system is not available, or we can introduce one more part to our architecture, which is a queue. So we can, let's say that when there's a problem in our system, when our system is not in sync, so we can queue those requests and we can return a response, something like expect delay in processing requests. And again, in both of these cases, our system will not be available sometime, or we will have delay in processing the messages. So our system cannot be all of three. So it cannot be available, consistent, and not in sync, which means that the partition tolerance at the same time. So to sum up our 7.CAP theorem, what we can tell? We can say that if our system is available, consistent, so it means that it's a centralized system, there is no partition, right? So there is no partition tolerance. And if our system is available and it's working when there is a network issue, or some other issue when we cannot keep our system in sync, then our system will not be consistent. So which is okay. So for example, if we are a building system which doesn't need to be consistent right away, so we are okay if there is eventual consistency, then we can pick this option. So the last option is that our system, if we want to keep our system consistent, and if we want to work with when our system is, when there is there is an issue, there is a network issue or some other issue, then in that case, our system will not be available. So as we have seen that from the previous example, it won't be, so we may have two choices, right? We may have actually more choices, so depending on our needs, but the very, on high level, we may have two choices. The first choice is that either we will have a delay in processing our messages, or our system will not be available for some time. Okay, that's it for the 7.CAP theorem. I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.